All right, you guys, so we are still in our using congruence and similarity with triangles. This is slide number 10. All right, so we use GeoGebra to explore. All right, so click on our congruence criteria to prove relationship GeoGebra activity. All right, so All right, so I've got two triangles here. They appear to be scalene and obtuse. Other than that, I have no clue what to do with them. All right, so measure and record the lengths of the sides A, B, C, and F, G, H. All right, well, we know how to do that. So there's A, B, B, C, A, C. All right, so it looks like AB is 5, GF is 5, AB is 5, GF is 5, BC is 12.65, so is HG. They're both 12.65. All right, AC. AC was 15, HF is 15. So based on side, 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 these two triangles are the exact same triangle. Not sure that's what they're asking, but that's what we know so far. Okay, how are the two triangles related? Well, let's see. They're congruent by side, side, side. All right, they are congruent. Whoa. Side, side, side. Gosh. You'd think I was a geometry teacher or something. All three sides are the same, y'all. Side, side, side. Look at that. All right, question 3. Determine the length of the base and the corresponding height of ABC, and then use them to find the area. Oh, okay, we're finding area. All right. So I got to find the base and the corresponding height of ABC. Well, the base is 15, because that's the length runs from A to C. The height is this right here. Now, it's not the 5. It's not the AB. Let me move that over to the side there. Let me move that. Get over there. That AB is what the 5 is. I'm talking about this height from 5 to 1. That is your height. That's the altitude of this triangle. So I got to count it as 1, 2, 3, 4. So the height is 4. This AB, that's that little segment right there. That's your 5. The altitude is 4. All right, so does anybody remember what the formula is? Formula for the area of a triangle? It is 1/2 base times height. 1/2 base times height. So I got to multiply 1/2 times my base, which was 15, times my height, which is 4. Let's see. Well, 1/2 of 4 is 2. 15 times 2 is 30. So it looks like to me the area is 30 here. So is that all I had to do? And use them to find the area of ABC? Yeah, that's it. Area is 30. Yeah, look at that. There you go. Question number 4. Determine the length of the base and the corresponding height of FGH, and use them to find the area of FGH. All right, and then ask me how this is related. Well, they're the same triangle, so they're going to be the same area. All right, but this one is not as nice and, visual. But it is going from 16 to 20. 16 for this line, 20 for my G is. So I'm going to count it. It's going to be 1, 2, 3, 4. For you visual people, it's going to be this segment right there. So if you're a visual person, you can see now it goes from 16 to 20. So the altitude is going to be 4. All right, so one more time. That formula is 1/2 BH. So 1/2 times 15 times 4. And we already know that's going to be 30. And again, how is this related to the triangle ABC? They have the same area. Basically because they are the same triangle. All right, question 5. Perform any sequence of 3 rigid transformations on triangle ABC to change its position. Okay, so I'm not mapping anything, I'm just changing it. Be sure to form a polygon with points A, B, and C as the vertices before performing the transformations on the triangle. Also consider turning on the grid. Record the sequence of transformations that you used, then calculate the area. Well, okay, first off, how is the area of the image ABC related to the area of ABC? All right, first off, it doesn't say anything about a dilation. All it says is 3 rigid transformations, which means I can do a translation, a reflection, or a rotation. Now, we have learned that rigid transformations keep their size. So the area of the original figure will be the area of the new figure. So doing a sequence is not going to change the area. But that's what they want me to do. That's what I'm going to do. All right, so they said to turn it into a polygon first, so let me do that. So, I'm sorry. We've never done that before. Go to the little polygon. Click on A, B, I'm sorry, C, B, and then back to A. So I turned it into a solid polygon. And now I'm going to do something to it. So I got to do 3 things. It doesn't say what to do. Oh gosh, I love reflections. Reflections are easy. Let's do a reflection. All right, so I'm going to come over here and I'm going to reflect about a line. And I'm going to do the x-axis. I'm going to click on this figure, click on the x-axis, and bam, there it is. There's 1. So I have done reflection of the x-axis. All right, what you want to do now? Another reflection? Yeah, let's do another reflection. Reflection across the line. So I'm going to reflect this figure across the y-axis. Boom. Move that over so you guys can see. So all I did is go woo over here. So just flipped over. All right, so I did a reflection across the y-axis. All right, y'all, I got to do one more. As long as it's a reflection or rotation, how about we do another x-axis? That'll put it right up here, and I'll get like a little nice little 3-dimensional UFO. All right, so I'm going to do a reflection across the x-axis. So click on your object, click on your x-axis. Oh, I'm sorry. I'm not under reflection about a line. My bad. Reflection about a line. Click your figure. Click the x-axis. Yeah, I got a nice little UFO looking thing. I love it. All right, so I did a reflection across the x-axis. All right, so there's my 3. And I already know the area is going to stay the same, y'all. I mean, look, my height, my altitude stayed the same. From C to A stayed the same as from C to A. So my area is not going to change because my figure didn't change. It didn't dilate it. So calculate the area. The area equals 30. And the areas are the same. Not going to change. I didn't do a dilation. All right, self-evaluation. All right, sweet. There we go. So submit that. Well, that was slide 10 of 25, so I'm sure I'm going to come back and do another one.